Imagine traveling non-stop at up to 670 miles per hour, above land or underground. This is Hyperloop, a new mode of transportation that has been developed by Hyperloop One. It starts with an electric motor, which is broken up into two basic components: the rotor, which rotates, and the stator, which is stationary. The stator is an electromagnet, so when an electric current passes through it, the rotor is magnetically attracted to spin. Unlike a normal electric motor, the Hyperloop One motor isn't circular, it's linear. And the rotor is on the pod, which is propelled magnetically as it moves over the stator. Hyperloop One's unique technology uses magnetic levitation to guide and lift the pod off the track. Nearly all of the air inside the Hyperloop tube is removed using a series of vacuum pumps. This effectively creates our own sky inside the tube, as if you are quietly flying at 200,000 feet above sea level. This reduces drag so only the smallest amount of electricity is needed to achieve extraordinary speeds, and creates a more cost and energy-efficient system than high-speed rail or airline transport. Hyperloop One will be automated by the most advanced systems in the world, allowing a safe and efficient journey that's never delayed or overbooked. Hyperloop is the first new form of public transportation in over 100 years. Fundamentally, it will change the way we travel, work, and live. Welcome to the future. Welcome to Hyperloop One. The Hyperpod is the long-haul vehicle of the Hyperloop One system. It is a comfortable and safe transport hull for passenger and cargo pods. All levitation and guidance systems fit seamlessly underneath. Secure airlocks are at each end. Inside the Hyperpod, passenger and cargo pods can glide smoothly at airline speeds right to their destination.
Going up to Devloop for the first time was seeing just unbridled opportunity. You saw the desert completely bare, and you saw in your head, in your mind's eye, what we were going to put there. I felt really confident because I have a tremendous confidence in the people that I work with and the people on the team that I helped build.
You've got teams from mechanical design, teams from computer engineering, and people who've worked on massive motor systems, massive rocket ships, and aerospace, aerodynamic engineering.
It was actually a really cool thing to see that once we were able to give good coordination and prediction to the manufacturing team actually building the motor, the construction and install team in Las Vegas was able to continue moving flawlessly and really pull in our timelines.
The number of people we have in engineering and in other parts of the company that we can honestly say are the planetary masters of their art is significant.
This thing that started as a sketch and an idea and then lived on this computer is now real, and it's welded and it's bolted and you can put your hands on it, you can hammer it, and then we actually assemble all the parts onto it and send it up to site, and you flip the power switch and it just comes to life.
The first time the pod levitated is definitely, that's the moment where it's like, oh yes, it worked.
That's really the engineering dream, to get to see that whole process through.
We broke all Hyperloop speed records. And to think we did all this in 10 months. We proved to the whole world that we can build safely, quickly, efficiently, and prove the technology works. This is just the beginning.
Now what we're doing is we're optimizing, we're refining. So we're going to continue to do testing on that bed. We're going to do some optimization to the hardware, to the software, to the controls, to take us to the next level.
I can't wait to see what we do next as a team.
My name is Sébastien Vignon. I'm the VP of Pod Engineering. I'm in charge of the development of the integrated pod. So that includes the design, test, and certification of the pod. We are creating a new mode of transportation, and that mode is sustainable. I've designed, tested, and certified aircraft, but aircraft, they generate emissions and they pollute. So now the fact that it is a fully sustainable product, I just love it. I am an aerospace engineer. I've spent 15 years in the aerospace industry. I studied at Dassault Aviation in France. I worked on the development, test and certification on the Falcon aircraft, which are business aircraft. Then I moved to Bombardier in Montreal, and I pretty much worked the past 8 years on the development of the Global 7500 aircraft, which is the largest and longest range business aircraft in the industry. So an Hyperloop pod is very similar to an airplane, but also very different. It's a highly integrated system with very complex interactions. So it's all about managing the interfaces and making sure that it is safe. It's kind of an airplane flying in a tube in low pressure, but on the other side, it's also very different because it's a mass transportation system, like a train. So we're looking at very high throughputs. And it's also an on-demand system, direct to destination. So it's kind of also like an autonomous car. So what are the main challenges of designing a pod and designing an Hyperloop system? The first one I can think of is that it has never been done before. This is a first in the history. And so we are learning a lot as we go. We do tests very often. We learn from those tests. So that's very encouraging. And the second thing is that there is no regulatory framework. But we're making very good progress. We're seeing very good initiatives in the US, in Europe, in Canada, and also in India, where committees are set up to investigate how to address the Hyperloop, so that's very encouraging as well. One of the reasons I'm here also is that that's something that my wife, my kid, even myself, we could use one day.
So how does a Hyperloop work? Well, we have a tube, and that encloses a low pressure environment. It's like flying at about 200,000 feet of altitude. And in that tube, you're able to go up to about 700 miles an hour. And you're using magnetic levitation. It's not your grandmother's form of magnetic levitation, it's our form, something that we've invented here in the last 2 years. And that allows you to glide smoothly over very rough surfaces for multiple miles with very little energy consumption. And then we use a linear electric motor, and that gives you your propulsion down the length of the track. So with that, you're able to go the speed of an airline at the convenience of a train. Is this possible? Investors are asking that, customers, regulators, you name it. And so we set out this company to show that not only was it possible, but it was transformative. So we based the entire company around our Devloop, which was showcasing all of these things working together, from levitation, propulsion, the vacuum system and the control system all working together. And we got that at our test facility in Las Vegas last summer at up to about 400 kilometers an hour. So to ride on a Hyperloop is actually going to be one of the most seamless and enjoyable experiences that you'll have. You'll start off, which will feel like an aircraft to take off, about 0.2 Gs. And then once you're up to speed, there'll actually be no turbulence. So that nice coffee that you have, that martini that I know that you enjoy, they'll all be sitting there very nicely on your tray table. This is something that you ride every day. It's not a roller coaster. It's kid-friendly, grandma-friendly, and more importantly, vomit-free. All right, so how many people can ride on a pod? It's about 20 to 25. And why did we select that number? Well, it allows us to go direct to your destination without having to stop. You're not waiting for all these people to show up. And you can leave when you want to leave, and you can arrive when you want to arrive. And one of the questions that we do get a lot is what happens if there's a breach in the tube. So we're designing our system to be able to take that into account. So if there's a small breach, the pods just experience a little bit of drag. They would end up slowing down using more energy. If there's a larger breach, then the pods just come to a stop safely and allow the passengers to evacuate if they need to. Is this the same system that Elon Musk put out in his white paper? The answer is no. One of the differences between what the white paper called out and what we're doing is the levitation. And so in the white paper, they talked about air bearings. We tested them. They have a very large energy consumption. And additionally, they ride very, very close to the surface. So think of a couple pieces of paper, which just isn't good enough for something that's going to be built over miles and miles and miles. So we switched because of the testing that we did, because of the development of the system that we have. We built our own magnetic levitation system. This isn't what the Germans used or the Japanese used. This is one that we've developed that's far cheaper. It allows you to go far faster, and additionally, it gives you a much, much, much more efficient energy profile. So we have the ability to tunnel. One of the things about our system is a two-way Hyperloop tunnel is smaller than a one-way high-speed rail tunnel. So it allows us, where we do have to tunnel, to be quite a bit cheaper, faster, and more efficient than other conventional methods. And then for us, as we go forward, most routes have about 30% tunneling. Are there any other full-scale Hyperloop test tracks? No. We're the only company that's built a full-scale test track with a fully integrated system showcasing how all of the parts work together. And we've run over 400 tests on it. 4 years ago, people didn't think this technology was possible. Now we have 4 different feasibility studies here in the US and Colorado, Missouri, Texas, and the Midwest. In the Middle East, we have numerous projects, as well as in India in the state of Maharashtra, connecting Mumbai to Pune. And that's really where we hope to break ground next year. The most frequently asked question that I get is not, is it possible anymore? It's, when can I ride it? And we're talking mid-2020s. We're talking about years, and we're not talking decades.
we're driven to explore, to connect, to innovate, to muster the courage to take a giant leap forward. The time has come to ask ourselves again, what is the future we want to build?
All right, team, please confirm you're ready. Ready.
Ready.
Capcom, you are a go for launch countdown.
Pegasus, this is Capcom. Prepare for launch in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, launch.
Today, the first people traveled safely on a Hyperloop. Tomorrow, Virgin Hyperloop will change the way the world moves with an on-demand, sustainable mass transportation system that connects cities in minutes. The future of Hyperloop travel is real, and the moment is now.